Welcome back, team. Now the scenario, I'm just placing a scenario here, team. Okay, very simple scenario. You just come here. You need to understand on few things. Okay, first and foremost thing, this IP address, this particular collection of IP address, is actually holding really 1,000 IP addresses or not. That is what Naga is calculating. You may have some doubt here. What is this number and how to calculate and how to refer? Let's understand that one. Remember one thing, team. What I'm doing here, I'm just elaborating this particular value, whatever they share. Remember, always the IPv4 address is this is called IPv4 address. IPv4 address is a collection of 4 octet. Octet 1, octet 2, octet 3, octet 4. 4 octet. Why I'm calling octet? 8 bits dot 8 bits dot 8 bits dot 8 bits. Sorry, 8 bits slash 22. That is a level of next level of detail. I'll go further one more level, okay? Okay, what exactly this 8 bits? You know that very well. We learned in our childhood classes the binaries 0 and 1, true or false, right? You know that. So each bit possible value is either 0 or 1. That's all. Now, 8 bits. Can you please write what are those 8 bits? Let me write a generalized 8 bits format first, okay? For example, I'm just keeping this one on the left side. I'm taking one more on the left side. Sorry, I'm keeping this one right, and I'm taking one more on the right side. I just want to elaborate what is 8 bits first, okay? You know very well that if you recall, team, one interesting fact, 2 power 0. If you recall one interesting fact, I don't know whether you can recall or not. The first position usually will bring from 2 power 0, 2 power 1, no dot, no dot, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, right. Now, correspondingly, can you please place a value? I'm just placing a value, team. What is 2 power 0 means? 2 power 0 means 1, correct? 2 power 1 means 2. 2 power 3 means 8. Sorry, 2 power 2 is there, right? Yeah, 2 power 2 is 4. 2 power 3 means 8. 2 power 4 means 16. 2 power 5, 32. 2 power 6, 64. 2 power 7, 128. See, team, if you recall this particular thing, whatever I just mentioned, this is a common math which we learned in our childhood classes. Okay, binaries. Okay, 2 power 0, 2 power 1, 2 power 2, something. The same thing is exactly representing 8 bits here. Exactly representing these 8 bits. See, meaning that now I'm going one more level. Now I'm asking you, can you please write a binary for this 10, value 10? This particular absolute value 10, can you please write a binary? If you come here, team, 128 must be 0, you don't need to worry. 64, 0, 32, 0, 16, 0. Now, the value is 10, right? 8 plus 2 is 10, right? 1, 8th position is on. 4th position is 0 again. 4, number 4 is 0. Again, value 2 is on. Again, now value 1 is 0. That's all. You got it. This is the value of 10. Guys, agree or not? Agree or not? One more I'll do. A value of 20 we are going to write now. Just tell me value of 20, team. How? 16 plus 4 you need to make it on. Correct? 16 plus 4. So now what exactly we are going to do? 0, 0, 0, 0, 0. That is perfect. 1. Correct? Oh, sorry, 1. I think 0, 0, 0, 1, right? Then 0, then 1, then 0, 0. This is the value of 20. Agree, team? You understand? Now, for example, value of 3. So how to go to Yeah, how to go to the value of 3, team? I'm just writing value of 3 also. Okay, I'll give one more.
Last.
Yes. Yes. The last
2 digits will be 1 1.
Correct. Very good. So 0 0 0 0 0 0 1 1. Correct. This is value of 3. What is the next one? Value of 4. What is the value of it's a straight value which is available there? Right, 0 0 0 0. Right, 0 1 0 0. Right. So this is the value of 4. Now these are the values we derived already. That is what exactly I am placing here after a detailed discussion. Copy this and copy the 20. Copy this. Copy the 20. Copy this. Copy the 20. Copy this. Copy this value. Okay. Slash 22. I just see this value only. I'm going detailed and detailed. Okay. Fine. So far, okay. This level we understand. Okay. Next one. Now I'm going furthermore, team. Furthermore a bit. Okay. Now I'm asking you, what is this 22? That's the doubt we have now. You know very well that I already told you. Your IPv4 collection is, this particular address is 32-bit combination. 32 bits total. 4 8s or 32. Out of 32 bits, they are telling you 22 bits are reserved. 22 bits are reserved. So meaning that, so what exactly you need to do? If you just come here, team, I'm just keeping this one, okay? If you just come here, so this is the exactly the thing, correct, right? Yeah, this is the exactly the possible case, correct? Possible case of saying that I'm just 22, so 8 plus 2, correct? Yeah, I'm just giving a different color for this one, first and foremost thing. Just give this one, and I'm also a little bit rise on that value size, okay? Right, and also I'm just giving a strike for that. Okay, all right, team. Now what you need to understand here, team. So whatever the values been given there, okay, whatever the values been given there. For example, you are saying 10.20.3.4/22. Meaning that 22 bits, I haven't touched 8 plus 8 plus 16, 16 plus 6, 22. Out of this 8, 2 bits still left over. And last octet 8 bits are purely left over. 8 plus 2, 10 bits are left over for you. Now what I'm telling you, you can play with these 10 bits. You can play with these 10 bits, not with these 22 bits. These 22 bits are reserved. Reserved for what? Reserved for network. Reserved for network, team. Network. But these 10 bits, whatever left over, those are for you. Those are the ones exactly all our components, whatever our friend is thinking about to just provision in the cloud, maybe for app corresponding to the app service, for DB corresponding to the PostgreSQL, all those, our friend or all those components will be deployed in this particular 10 bits. Now, I'm going to check one more thing. With these 10 bits, I just want to see how many IP addresses are available. How many? Question number 1. How many IP addresses we can derive? How many IP addresses we can derive for host? You need to clearly tell us. For host, how many IP addresses? 2 to the power of 10, which is a 1024. Okay, perfect calculation. Now our friend Naga did a calculation and he got the value as 1024. That is what exactly Naga asked regional infra. I need 1000 IP addresses. They shared exactly 1024. Exactly 1024 they shared. That's what Naga calculated. How he calculated? Whatever the leftover bits are there, all permutations, combinations, we need to form these particular 10 bits. How many permutations, combinations will come is 2 to the power of 10. A total of 1024. Now, I'm asking one more question. Number of bits reserved for the network. I'm just asking one more question. Number of bits reserved for the network. Tell me, Chief. How many bits got reserved for the network? 22. And the question would be a bit different also. Number of bits masked in the given address space. How many bits are masked? 22. So for all these things, answers are same actually. Okay, answers are same team. Okay, answers are same. Say 22 bits. Okay, 22 bits are masked. Okay, and the number of bits reserved is 22. Number of bits are available. I'm asking one more question. Number of bits are available for host. How many bits are available for the host team? 10 bits are available for the host. Correct? 10 bits are available. Another question. Total number of bits available for IPv4 address. Total number of bits available for total number. It's a general question. Okay. Total number of bits available. Instead of saying total number of bits for the IPv4 address. How many? 32 bits are available. 32 bits are available always. Okay. Right. So, right. See, these are all the possible case and the possible value, especially for the given address space. So fine. Now, once you are done with this thinking, okay. Now, okay, we understand that we have a total of 1024 IP address system. Okay. Now, when you have a total of 1024 address space team, okay. Now we will discuss more on what is subnet. Okay. What is subnet? We will discuss this part team. Okay. But from the discussion, what we understand here is the provided IP addresses are 1024. Right? That's a number of IP addresses. Now the problem is, team, remember one thing. Whatever the components our DevOps engineer planning to use in the infrastructure, each component will take an IP address. Each component will take only one IP address. But tell me, total how many IP addresses are there? 1000 IP addresses. But is it really possible for a person to manage these 1000 IP addresses? Manage in the sense, you need to safeguard all these 1000 IP addresses are always safe or not. And legitimate traffic only always going through these particular IP addresses or not. Is there anything which is blocking these 1000 IP addresses or not? It is not possible for a person to check the 1000 IP addresses time to time. That is where we have a concept of subnet. Now what subnet is doing? The subnet is doing, subnet will divide your virtual network into different parts team. Okay, for instance, this is one subnet. Okay, this is one subnet. At the same time, I'm just keeping another subnet here, taking another subnet here, or something like that. Now, what exactly you try to do here? We try to divide your virtual network into subnets team. But how? How to divide this? Is it easy? Total how many IP addresses are available, team? 1000 IP addresses. If you divide, I just placed the four sections here. 4 subnets. Subnet 1, subnet 2, subnet 3, subnet 4. So 4 parts means 4 into generally 4 into 256 is the count exactly we need to derive. Correct? So each subnet should consisting of 256 IP addresses. That's all we need to do. Correct? That's all we need to do. To have 256 as the subnet, what is the subnetting value you need to provide? That's what just before you calculated. /24. /24 is the one which exactly help us to derive into 256 IP addresses. Correct? You know this already. Just before I gave the same example. Okay. /24. Now the point is how to divide our VNet into different subnet. That's exactly the question we have. This one easily you can divide by using Azure component. That's very easy also. Let's go to portal. Let's go to a VNet virtual network component. I'm just going to the virtual network. Please go there. please create a virtual network. I'm creating one virtual network name. The virtual network is the one just before our infra engineer provided us, right? Regional infra engineer. The same thing I'm using, okay? I'm using the same resource to go for the next. Go for the next. Here is the IP address space. Okay, now tell me, team. Tell me, our friend gave some cider for you just before, right? Some cider he has given. What is the cider? 10 dot, whatever the value we just calculated. That one I'm talking about. 10.20.3.4, correct? 10.20.3.4 slash 22. 20 slash 22 is the one 1024. Slash 24 is the one 256. It's giving a very good explanation here. Slash 22 is the one exactly the 1000 address space, right? Exactly. So what happened? So okay. So what exactly it is saying? Oh, it is not a valid CIDR block. Use 10.0.0 slash 22 or 4.0. Okay, fine. So not a valid means I think this might be the one which might be reserved for some other thing. So what exactly I'm doing now? I think whatever they're recommending, I'm just using the same thing, team. Okay, 0.0 slash 4. Okay. So that is the one. Just a moment. Just a moment. Perfect. Okay. Perfect. 1 second. I'm just clearing the subnets, whatever is available. So a little change on the virtual network value, whatever we picked up. Okay, I'm just changing that one because the previous one, whatever we picked up, we just assumed that one. That's not a valid CIDR. So that is why I think don't pick that one. I think that's saying pick this 10.20.0.0/24. Alright. Now the point is, Steve. Now, when you see this particular slash 22, so it is already giving 1000. Okay, I'm a little change on this particular correction team. I'm just doing the correction very quickly. 0.0 and followed by the calculations and all same. Especially the one interesting one, this should be the 00. So that's the only thing. And by the way, this is should not be strike. That part you know already. I'm just keeping that one in the black only. That's correct only. 2 to the power of 10 is okay, 22 is okay, given 22 is okay, 10 is okay, this and all fine. Okay, no problem with this. And especially when you calculate the value, I think that's corrected, and this is also 0 team. Okay, that's all. Okay, that's all. That's the correction exactly. Now you just come here. Okay, we corrected that one. Now we need to divide this CIDR into subnets team. Click on subnet. When you click on the subnet team, it is asking you to generate a on subnet. Okay. So now you are seeing very clearly here. So this is your virtual network. Here the subnet template is default. Keep that one. And next one is a name is a default one. Okay, you can give some name. Okay, I want to create one subnet only for VMs. Okay, VM subnet. I'm just creating one VM subnet. It is already recommending me 10.20.0.0/24 use it. You can get 256. You got my point. It is just asking me. Okay, instead of what is this one? Sorry, yeah, all right. Yeah, see. So what? See, now it is asking me already. /24 is the one which please use /24 so that you will get 20. That's good. That's good. But the series, note the series team. 10.20.0.0. Okay, fine. Okay, VM subnet. I'm not attaching any kind of NAT gateways or security groups or route table. Not attaching anything. Okay, all right. Go for the another subnet. Next one, I'm just going. One more. I'm just going here. This time, I'm just giving this particular subnet for app service or DB subnet. Okay. I want to create one subnet for the DB. See, perfectly all right. It is already recommending you. Please use this one, which is another 256. That's good. And go for one more. I'm just clicking on one more time. Okay. One more time. Now see, it is going for the 10.20.2.2 series. Okay. Again, it is asking you, please pick one more. Sure, definitely. I'm just taking one more as an app service subnet. Okay. Something like that. App service subnet. Okay. This is also good. And one more I'm going to create 4 subnets, right? I planned. The 4th subnet is this one, which is already recommending. I'm just giving some name saying that additional subnet. Additional means for backup. In future, I may require to deploy one more component. This particular address space will be used at the time. That's all. Total 4 subnets are created. And guy, finally a review and final validation failed. Let's go to the validation. What exactly the validation? So check user quota. Just a second. Raw error. I don't see any error. Just let me see one more time. Maybe we may miss some namings or something. Just a second. IP address section. I don't see any error on the IP address section. Okay, I go for the next. No need to give any tag. Not required really. Validation failed. It is showing again. Just let me see on the basics part also. Is there anything we miss? Yeah, virtual network name we have not given, right? So that is the thing exactly you need to give. AZ-VNet, right? Now you go for the VNet, review and create. If you go there and create at the virtual networking is created. Now you know what exactly you did, team. You just come here, you created 4 subnets. One is VM subnet, team VM subnet, and another one is DB subnet, correct? DB subnet, another one is app-hyphen subnet, then another one is additional subnet, correct? That's the thing exactly you did, team. Now I'm going to do one interesting thing, team. We have created a VNet and subnets also. Thank you for the session. See you in the next part.